Hey guys, today we're going to learn about box plots. They were formerly called box and whisker plots, if you remember from 6th grade, but now they just refer to them as box plots. So we're going to learn some vocab and how to take data and create our box plot. So that's our goal for today. I'm going to go ahead and share my screen to get started. So here are our box plot notes, and I can see while I was playing around I added an extra letter there. All right. So a box plot shows the 5-point summary of a set of data. So we've been talking about data all week with histograms and dot plots, and now we're talking about box plots. So it's just a 5-point summary of data that's been provided to us. So first we have our lower extreme, okay? And our lower extreme is clearly the lowest value of a set of data, also commonly referred to as our minimum. So lower extreme, lowest value, or our minimum. Those are all different ways that you can see this being referred to on a test or in any type of practice problem. Okay, so lower extreme, minimum mean the same thing. Blank is the middle or median of the lower half of the set of data. So it's the 25th percentile of the data. So that is going to be our lower quartile, okay? Our lower quartile, also referred to as our Q1, okay? So our lower quartile, or Q1, is the middle of our lower half of the data. So it's the middle of our lower half of data. Blank is the middle number. Well, we've talked about that a few times this week. That is our median. Our median is the middle number in our set of data. Okay, our median. Our upper quartile or commonly referred to as our Q3, our upper quartile is the middle of the upper half of the set of data. So that is where our 75th percentile of our data. Okay, it's the middle of the upper half of our data. Blank is the highest value in the set of data. So that would be our upper extreme. Okay, our upper extreme is the highest value. And this is also commonly referred to as our maximum. So upper extreme and maximum can be used interchangeably, and that is the highest value in the set of data. Then finally, we have our IQR, our interquartile range. Okay? Our interquartile range. Is our IQR, and that is the middle 50% of data. Okay, when we're talking about box plots, this is what we refer to the most, is our middle 50% of data is our IQR, and that's most often what you're going to need to find. And to find your interquartile range, your IQR, you have to subtract your Q1 from your Q3, okay? So our Q1, our lower quartile, we have to subtract that away from our upper quartile range, our Q3. And then that's how we find our interquartile range. So we will practice that in just a moment with a set of data, but I've provided a box plot below for us to map out so you have something to refer to with all of our vocabulary words. So first we have our lower extreme, our minimum, okay? Lower extreme, minimum. Then we have our lower quartile, our Q1. Okay, our Q1 is just the middle of our lower half of data. Okay. Then we have our median, which is just the middle of our data. That's the line in the middle of the box. Okay. Then we have our upper quartile, our Q3. And that's the middle of our lower 50% of data. Our Q3 is the middle of our lower half of data. And then finally, we have our upper extreme, or our maximum. Okay, and then finally, we have our interquartile range, which is just the middle 50%. Okay, our interquartile range or IQR. IQR. Okay. All right. So now that we've learned all the different parts of a box plot, let's learn how to either read them and then how to create our own. So it says Megan asked her classmates is what that should say, how many hours they spent on homework this week. The box plot shows the data she collected from 20 students. Okay, so it says, what is the median number of hours spent on homework each week? So our median is right here. So what is the median number of hours spent on homework each week? Well, that would be 10 hours. What is the maximum time spent on homework each week? Okay, our maximum is right here. So our maximum number is 18 hours. What percent of students spent between 8 and 13.5 hours on homework each week? Okay, so we're looking from 8 to 13.5. Well, what percent of students is that? Well, that's our middle 50%, because that box, the box is always going to be, or the IQR is always the middle 50% of our data. So 50% of our students, studied between 8 and 13.5 hours. Then it asked, what is the interquartile range? Well, to find our interquartile range, we have to subtract our Q1 away from our Q3. So that is going to be 13.5 minus 8. And that will equal 5.5. So our interquartile range, our IQR, is 5.5 because the 13.5 is our Q3. Okay, and the 8 is our Q1. So to find our IQR, we just had to subtract Q3 from Q1. All right, so our first example problem is finished. Now let's move on to our next one, where it says reading box plots. Okay, so they provided a box plot for us. These are height of vases at Pete's Pottery. So I can see that my minimum value is 6, my lower extreme, my maximum value, my upper extreme is 12. I can also see that my median is 8, and my interquartile range would be 11 minus 7, which is going to be 4. So I can just observe that just by looking at the box plot. So it says the maximum value is 13. Well, no, our maximum value, I'm sorry, I'm just trying to make sure that we keep highlighting by the same color. So the maximum is purple, okay? So my maximum value here is 12. So with a maximum value of 12, I know that this statement is false because it should say 12, okay? The median is 8. Well, the median is in fact 8 here, so that is true. And if I want to highlight it the same color as I did before, my median was pink. So here's my median, and yes, my median is 8. That is true. The range is 7. Well, the entire range, because it didn't ask for interquartile range, it just asked for the range. Okay, the range here goes from 6 all the way to 12. Well, 12 minus 6 is not 7, it's 6. So that's false because the answer should be 6. The interquartile range, the IQR, is 7 to 11, and 11 minus 7 we've already determined is 4, so yes, that is true. The minimum value is 6. Yes, the minimum value is 6. That's right here. And finally, it says the 50% of data is more than 8. 50% of the data is more than 8. Well, what that is asking is 50% of the data, right? Because this is all broken into quarters. So 25%, 25%. And yes, that is true. 50% of the data is more than 8 because your upper 50% starts at 8, your lower 50% also starts at 8 because your median is 8. All right. Use the given information to create a box plot. Be sure to give the graph a title and a label. So here we're provided the data, and we have to take that data first, and our first step is going to place it in order. Okay, so looking at our numbers, we need to place this data in order. So I'm going to start with 20. Then I have 21, 22, 24, 25, 34. Oops, I forgot one, 26. So I'm going to erase that 34 and put 26. Now I'll put the 34. Oops, and look at, I forgot another one. 28. Then 34. Then 35, and then 39. 35 and 39. Almost out of space. All right. Now that I have all of my numbers written down, I need to look for the middle number. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 data points. So the middle is going to be right here. So 1, 2, 3, 4, 1, 2, 3, 4. So to find my median, I need to add 25 plus 26 and divide by 2, and I get 25.5. So that is the median for this set of data. So I can put my line there. Okay, median 25.5. To find my lower quartile, okay, my minimum, that's really easy, I'll do that first, is 20. My maximum is going to be 39. My Q1 is going to be the middle of my lower half of data, okay? So this was where my half of data, so to find the middle of that, it's going to be 22. And the middle of my upper half of data is going to be 34. So there was my median. My Q1 is 21. My Q3 is 34. And then I need to add my whiskers, and that's going to go out to 39. And this is going to go down to 20. So there I've created my box plot for that set of data. All right, guys, I've got to go. Have a great day. Bye.